Consider the following: 2 to the 7th divided by 2 to the 4th power. One way to do that is to figure out what 2 to the 7th power is. So 2 to the 7th power is a pretty big number, so maybe you got to use a calculator for that. So if we were to do that, then we would get 128. 2 to the 4th power is 16. And when you divide 128 by 16, you would get 8. So that would definitely work with large numbers, but you probably need a calculator for it. Remember what 2 to the 7th and 2 to the 4th actually mean. 2 to the 7th power means 2 times 2 times 2 times 2 times 2 times 2 times 2. And 2 to the 4th power means 2 times 2 times 2 times 2. Well, we got a lot of 2's being multiplied in both the numerator and the denominator, so what we can do is start crossing out, canceling out pairs of 2's there, which means what you're left over with is 3 2's, or 2 to the 3rd power, and that equals 8. Notice we did that entirely without using a calculator by canceling out all those 2's. Same concept can be applied to variables. If you have t to the 4th power, that's t times t times t times t. T to the 3rd power is t times t times t. And if you cancel out matching t's there, you're left with 1t on the top, so the answer is just t. Well, there's got to be an easier way to do this than to write out all those numbers and all those variables and cross them out. And maybe you've already noticed the pattern already, but we can do the same thing by just subtracting the exponents. So just like yesterday or last section, 7.1, where when you multiplied exponents, you add them. To divide two powers with the same base, you can subtract the exponents. So for all non-zero numbers a, that means if you have m and p, you can just take the m, the exponent in the numerator, minus the exponent in the denominator. So a couple examples that you see here is that if you have c to the 11th divided by c to the 8th, you would just take 11 minus 8, and that would be c to the 3rd. If you have r to the 5th divided by r to the 2nd, what's 5 minus 2? Well, 5 minus 2 is 3, so that is the same as r to the 3rd as well. So let's do some other more complicated examples. Simplify g to the 3rd over h to the 5th over gh to the 2nd. Assume no denominators equal 0. That just simply reminds you that you can't have 0 in the denominator because you can't divide by 0. We're going to divide the exponents by subtracting them. So we have g to the 3rd in g, and that would be g to the 1st power. So if I put in g to the 1st power, that means I would have 3 minus 1, which is 2, so g to the 2nd power. H to the 5th divided by h to the 2nd, 5 minus 2 would be 3, so that would be h to the 3rd power. So g to the 2nd, h to the 3rd. 1b, we can subtract the k's exponents, so k to the 7th divided by k to the 5th. Even though it's same divided by, the process for division is subtracting the exponents, so that would be k to the 2nd. M to the 10th divided by m to the 3rd is m to the 7th, because 10 minus 3 is 7. And what about the p's? So that would be p to the 1st divided by p to the 1st. That would be 1 minus 1, which is p to the 0 power. Basically, those cancel each other out, so I don't have any p's on the answer, so it's just k squared m to the 7th. In section 7.1, we learned that they have power of power. Power of quotient also works. It's the same as power of power. Just simply means that if you have a division problem with an exponent on the outside, then everything affects both the numerator and the denominator is affected by that exponent. So notice that 3/5 to the 4th power means 3 to the 4th over 5 to the 4th. Both the 3 and the 5 will be to the 4th power. RT to the 5th power means the R will be taken to the 5th power and the T will be taken to the 5th power. So if I'm simplifying 3p to the 3rd over 7 and all of that is squared, remember to follow your order of operations. Look inside parentheses to see if anything can be simplified there. It can't, so now we're just going to take every part to the 2nd power. Remember, this 3 is not an exponent, so we're not taking 3 times 2. We're taking 3 to the second power, and that will be 9. And then p to the third to the second. So we have two exponents sharing the same base. And as we learned in section 7.1, when two exponents share the same base, we multiply the exponents. So that will be p to the sixth power. And then 7 to the second power will be 49. That 7 will not be multiplied times 2. It is 7 times 7 because it is not an exponent. 2b, we cannot do anything inside parentheses, so take each piece to the second power. So 5 squared is 25. X to the fifth to the second is x to the 10th because 5 times 2 is 10. That will be y to the first to the second, which will be y squared, all over 6 squared, which is 36.